In this video, we are going to discuss questions related to boats and streams. There is a certain set of questions where a boat or a person is swimming in the water, and there are three situations that can arise. Either the water is still, or the water is moving in the direction of the person swimming. The first scenario can be where the person is swimming or the boat is floating in still water. That is, the water is not moving, such as when we see water in a lake or water in a stationary body, water in a lake or a pond, the water is still, water is not moving, but the person can swim or the boat can be floating around. The other scenarios can be that the water is flowing. For example, water flows in river and the person is flowing along the river, that is with the flow, or the person is flowing opposite the flow of the river. So we need to understand these three terminologies. If the person is swimming or the boat is moving in still water, that is in stationary water, then this is the first scenario where the speed of movement in water will be the speed of boat itself. So if boat is moving with the speed of u, then the speed of movement is u only. There is no other factor. Second scenario is that the boat is moving in the direction of the stream. So if the stream is moving in the right direction and the boat is also moving in that direction, then it is called downstream. In this situation, if boat has a speed of u in still water and the stream is moving with the speed of v, then the effective speed of boat is going to be u plus v. Flow of the stream will push the boat further and increase its effective speed. The third scenario is when the boat is moving in the opposite direction of the stream. This is called upstream movement. When a boat is moving upstream, the effective speed of boat reduces. So if boat moves at a speed of u in still water and the stream is moving at a speed of v, then the effective speed is going to be u minus v. So these are the three scenarios. Either in still water, the boat is moving it at its own speed, which is u, or it is moving along with the stream at a speed of u plus v, or it is moving opposite to the stream at a speed of u minus v. So usually in questions, if we are given the speed of boat, that is speed of boat in still water. It is usually given only in still water and not in downstream or upstream. If it is downstream or upstream speed, it will be specifically mentioned in the question and we have to act accordingly. Now let us look at some examples. So the speed of boat in still water is 20 kilometers per hour. So we are given the value of u, it is 20 kilometers per hour. If the speed of stream is 4 kilometers per hour, what will be the downstream speed and upstream speed? So downstream speed means that the boat is moving in the direction of the stream. So 20 is the speed of boat plus the speed of stream. So it will be 24. And upstream means boat is moving opposite to the flow of the stream. So it becomes 20 minus 4 and this comes out to be 16. So this is how we find out downstream and upstream speed if we know the speed of boat in still water and speed of the stream. Now this is another example. A person can row at 7 kilometers per hour in still water. If the river is running at 3 kilometers per hour, so we are given the speed of stream also. It takes 6 hours more in upstream than to go downstream for the same distance. So how far is the place? So downstream speed is simply 7 plus 3. It is 10 kilometers per hour. So if the person is moving at 10 kilometers per hour and the upstream speed is 7 minus 3, 4 kilometers per hour. So if the person moves at 10 kilometers per hour and then he moves at 4 kilometers per hour, if he travels the same distance, he will take additional 6 hours while traveling at a speed of 4 kilometers per hour. So this is the equation that we have to write and solve. So let's assume that the distance between the 2 points is x. If we are moving at a speed of 10, the time taken will be x upon 10. And if we are moving at a speed of 4, the time will be x upon 4. And we are given that x upon 4 minus x upon 10 is equal to 6 hours. So we just have to solve this equation and we will get the value of x. So x comes out to be 40 kilometers. Let's look at another example. Now the person can row at a speed of 6 kilometers per hour and the speed of stream is 2 kilometers per hour. The total time taken to move down the stream and then up the stream to return to the same place is 3 hours. Now we can easily find out how far is that place. So if we assume that the distance is x kilometers, x upon 6 plus 2 plus x upon 6 minus 2 is equal to 3. So x upon 6 plus 2 is basically the time taken to move downstream, and x upon 6 minus 2 is the time taken to move upstream, and the sum of these two times is the total time taken, which is 3 hours. So let's solve this. So x comes out to be 8 kilometers. So this is how far that place is. So I hope you understand the concept behind this kind of problems where boats and streams are involved. Boat has its own speed in still water and there is some additional speed of the stream which may be added to the speed of the boat or subtracted from the speed of the boat, and we have to calculate the distance traveled or the time taken accordingly. Now let us look at some practice questions related to this topic which we often see in the competitive exams. Now the person can swim with the stream at a rate of 3 kilometers per hour. So what this means is the downstream speed is 3 kilometers per hour and against the stream at the rate of 2 kilometers per hour. So this is the upstream speed. How long will that person take to swim 7 kilometers in still water? So we have downstream speed and upstream speed. We have to find out the speed in still water and then we can easily find out the time taken to swim in still water. So 3 kilometers per hour, which is the downstream speed, is basically u plus v, speed in still water plus speed of the stream. Then this 2 kilometers per hour is u minus v, that is the upstream speed. We can solve this equation to find out u and v. We just need u here, so we will add these two equations up. So 2u is equal to 5. So speed in still water is 2.5 kilometers per hour. The distance is 7 kilometers. So what will be the time taken? Time is equal to distance upon speed. So this comes out to be 28 upon 10. So 2.8 hours. Here's another question. Alok rows a boat against a stream flowing at 2 kilometers per hour. So we have value of stream speed. V is equal to 2 kilometers per hour. Distance he travels is 9 kilometers and then turns around and rows back with the current. So first he moves against the current and then he moves with the current. If the whole trip lasts for 6 hours, find Alok's rowing speed in still water. So suppose Alok rows at a speed of u in still water. So when he is moving upstream, he will take time which is equal to distance upon speed. So distance is 9 kilometer divided by u minus v, u minus 2. So this is his time taken upstream. Then he is moving downstream. So time taken will be 9 divided by u plus 2. And the total time taken is 6 hours. So if we solve this equation, we will find out the value of u. Is equal to 6. This is a quadratic equation. 6u square minus 4 is equal to 18u. Minus 24 is equal to 18u. So this becomes u square minus 4 is equal to 3u. U square minus 4u plus u minus 4 is equal to 0. So u plus 1 into u minus 4 is equal to 0. So the two solutions here are u is equal to minus 1 or u is equal to 4. So since his speed is going to be positive, u is equal to 4 kilometers per hour. So the answer will be A. Now here's a slightly different problem. In this problem, we are told that the man rows boat a certain distance upstream and then returns to the same place. If the time taken by him in going upstream is twice the time taken in rowing downstream, find the ratio of the speed of boat in still water and the speed of the stream. So we are given ratio of time taken when the distance traveled is same. And we want to find out ratio of speed of the boat in still water and the speed of the stream. So when the boat is moving upstream, so the speed was u minus v. The upstream speed is u minus v and the time taken is 2t. So u minus v into 2t is the distance traveled upstream. Similarly, when the boat is moving downstream, the distance is u plus v into t. And since both the distances are same, we are equating them. So 2u minus 2v is equal to u plus v. So u is equal to 3v. So the ratio of u with v is 3:1. So the option D is the correct answer. So in this question, we did not calculate any speed. We did not calculate any distance. We just found out the ratio of speed of boat in still water with the ratio of speed with the speed of the stream. Now in this practice question, Rahul is rowing at a speed of 4 kilometers per hour in still water. So u is given to us 4 kilometers per hour. He has to reach a destination which is 130 kilometers downstream of a river. So he is moving downstream. The river flows at a speed of 2 kilometers per hour, but due to tides for 2 hours, it halves to 1 kilometer per hour for 2 hours. And then this goes on till the completion of journey. If Rahul starts with the river which started flowing at 2 kilometers per hour, then after how much time will he reach his destination? So let us understand what is happening here. Rahul is starting from the initial point and the speed of flow at that point is 2 kilometers per hour. After 2 hours, he reaches certain point, but at that point, the speed of flow reduces to 1 kilometer per hour. And this also continues for 2 hours. Again, the speed of flow increases back to 2 kilometer per hour. Then again tide comes for 2 hours and the speed becomes 1 kilometer per hour, and this cycle is going on. Now the distance that he is going to travel is 130 kilometer, and while he is traveling this distance, these cycles are going on and we have to find out how long he is going to take to reach the destination. So when the speed of stream is 2 kilometers per hour, his effective speed is going to be u plus v, which is 4 plus 2. that is 6 kilometers per hour. Then for another 2 hours, his speed is going to be 4 plus 1, which is 5 kilometers per hour. Now for the first 2 hours, when his speed was 6 kilometers per hour, the distance he will travel is 6 into 2, 12 kilometers. Then for next 2 hours, since his speed is 5, he will travel 5 into 2, 10 kilometers. So in one cycle of 2 kilometers per hour speed and then 1 kilometer per hour speed, he is traveling 22 kilometers. And this cycle is for 4 hours. So every 4 hours he is traveling 22 kilometers. Now he has to travel 130 kilometers. So in 5 such cycles, he will be traveling 110 kilometers. So already he has spent 20 hours to cover 110 kilometers. So just by looking at the options, you can take the answer right now that there is no such option which is more than 20 hours. So we can straight away take none of these here. But if you want to find out the correct answer, he has traveled 110 kilometers. Now only 20 kilometers are left. Now the first 12 kilometers will be traveled at 6 km per hour. So that is also subtracted. That will take 2 hours. Now the remaining 8 kilometers are to be traveled at a speed of 5 km per hour. So that will take 1.6 hours. So 20 plus 2 plus 1.6. So this comes out to be 23.6 hours. So this is the total time taken in this whole journey, where there were cycles of tide which led to different speeds for different duration of travel. So these are the concepts of upstream and downstream movement of stream, in which a person is swimming or a boat is moving, and you just have to add up the speed or subtract the speed of stream and use the concepts of speed, distance and time to solve the problems.